Okay, so exponential relations are modeled by the exponential equation y equals a b to the power of x, okay? Where a is the initial value, or amount, and b is the growth or decay factor. So if b is greater than 1, then we will have growth. So models growth. And if b is between 0 and 1, I should say here, so it's between 0 and 1, then it models decay.
0 point something.
Yeah. And if you guys remember, we talked about this before, so in the grade 11. So y equals a1 plus I to the power of x, or n or whatever, and y equals a1 minus I to the power of x, right? So where I is the rate, right? So the rate means if it's growing by 10%, right? Every month, every year, or whatever, right? If your value of this thing is growing by 10% every year. So what you're doing is that you're changing that I to 0.1, and then it's going to become 1.1. Okay? So then it's greater than 1, right? If we're talking about COD, and then the value of the COD is decreasing by 10% every year, then because it's decreasing, then we have to use the second formula. It's 1 minus the 0.1, which gives you 0.9 to the power of x. Okay? So that's a decrease, that's a decay. Okay? So this is where the formulas are coming from. So when you see something that looks like exponential, for example, in the next example, right? It's coming from this. Okay? We also have two other versions of the exponential growth and decay, and that would be the doubling time and the half-life. So when something is doubling or when something is half-life, okay? And that would be a little bit different, still the same idea. So it will be y equal a. Now for the doubling, it's going to be 2 to the power of x over d. The reason why it's over d here is because you have to account for how long it takes to double. So let's say if your doubling time is, let's say, 10 years, so every 10 years you're doubling, then your d is going to be 10, okay? And then x is going to be whatever the question is asking you for it to be. And then you have the half-life, which is a 1/2 x over h, where h is the half-life time. So if, let's say, you have a carbon-14, let's say, and then its half-life is 1,000 years. So every 1,000 years, it's going to lose half of its value. Then the h value is 1,000. Okay? Because you're losing half of it every 1,000 years. We're going to see examples. We're going to do some of these examples. Okay? But keep in mind that these are your formulas that you're going to see or use. So the doubling is going to be a growth, right? Because the base is greater than 1. And then the half-life is going to be the decay, right? Because the base is less, between 0 and 1. So a city's population can be by the equation P equals to 1.4. Bracket 1.0415 to the power of t, where p represents the population in millions, t years after 1985. In which year did the population first exceed 3 million? So, the beginning population is
1.4.
million, right?
Minute, sorry.
The ending population is?
1.0.
No, what are you gonna, what's the question asking you, what would you want your end population to be? So in which year did the population first exceed 3?
3 minutes.
So the ending population that we're looking at in this question is 3. Now, what's the rate the population is growing at? That is the growth factor. I'm looking for the rate. That means I'm looking for the I value. Okay? So how would I find the I value?
I will do 1 plus, sorry, percentage, so divide that, subtract.
Okay, so remember that this is 1 plus I, right? 1 plus I is 1.0415. Okay? So if you want to know what I is, because it's asking you for the rate,
Right.
right? So you have to take away 1, right? And then you have to multiply by 100 because you want it in percentage, so that would be 4.1.
So we have subtract, right?
Yeah, so you do 1 minus, sorry, you do 1.0415 minus 1. Okay? You guys okay with that? So if it's asking for the rate, so they want the percentage. If it's asking you for the factor, this would be the factor. So this number would be the factor, right? It's your growth factor. So, the question is asking you when or in which year did the population first exceed 3 million? So what letter am I solving for? T. Okay? So, P is 3 million. So I'm going to write 3 equals 1.4, 1.0415 to the power of T. I am solving for T. I don't know where it is. How would I solve for T?
Minus 1.
I can't multiply this and this because this is the only one that's the power of T. Okay? So what do I have? If I want to divide by 1.4 because you want to get rid of this, right? So it will be 3 divided 1. So what's 3 divided by 1.4? Should be
0.3.
no. It's
2.142.
Now, yesterday we did something similar to this but with whole numbers, right? And then we're making our bases the same, right? And then when the bases are the same, then the exponents are the same. You remember that from yesterday? Now this is kind of impossible to do that with decimals. Okay, you won't be able to find something to the power of whatever to find T. So we're gonna have to do guess and check. Okay, so we're gonna plug in values for T, right? Until we get the answer 2.143. Okay, so the values for T, if you start with 1 and 2 and 3 and 4, it's going to be very, very small, right? Because it's 1.0415, so you're not going to see it. So let's start with 10. Okay? So we're going to do guess and check. And then we're gonna do t equals 10. So what do you get when you do that?
1.50.
So that would be 1.502. Right? That's still too low, right? Because I'm looking for 2.1. So what would be your next one that you want to plug in? 20?
20.
Too much? Okay, so what do you get for 20?
2.255.
So that's too high?
Yeah.
Okay. So what do you want to plug in next? 18, okay.
It's
2.07?
Yes.
9?
90.
Okay. It's a bit too low, right? So maybe let's do 19?
Yeah.
Okay. So 2.165. So, I mean, the 18 is too low, the 19 is too high, right? So basically it's somewhere in between. So your answer is gonna be that between year 18 and the year 19, the population is gonna exceed 3. Okay? Because this is too low and too high, so we're gonna say that between the 18th year and 19th year, the population will exceed 3 million. Now, if I'm talking about the 18th year and the 19th year, from what year is that?
18 month year.
So what year is the year 0?
1 year and
The year 0?
Yeah.
1985?
So 1985 is my year 0. Okay? So that if I add 18 to it, so that will be 2003. So in about 2003. So between the 18th and 19th year, the population will exceed 3 million, so that's around 2003. Okay. Can I move to the next one? Alright, now, I've already talked a little bit about these two equations, right? So these are the special equations. This is when the question is telling you that your function is doubling, or your population is doubling, or whatever it is doubling, right? Or when you have the half-life, so it's half. So you're losing half of it every single time. And then I've already talked about how the formula looks like, right? Where A is your final amount, A0 is your initial amount, 2 is when you're doubling, so you put a 2 in there. T is a time measured. So when the question is asking you, what would be your population after 50 years? That's your T. Okay? D is your doubling time. So at the time the population, it takes for population to double. So the time it takes for the population to double. So if the question is saying this, you have a bacteria, you have 100 bacteria, and then the bacteria population growth is doubling every 5 minutes. What would your population be in 1 hour? So you're starting with 100 bacteria, doubling every 5 minutes. What would the population be in 1 hour?
So the T is at 5.
No. Let's start with 100. What does 100 represent? The initial. Okay. So 100 is replacing a 0. Then what do I put in my bracket?
So it's doubling, it's 2.
Doubling, that means it's 2. Right? Now, it's doubling every 5 minutes. So that 5 minutes represents what? Which time?
D.
No, it represents D.
D. Right.
Because it's the doubling time. So it's doubling every 5 minutes. Right? So that represents your D. Okay? Now, what do I replace T by? 1 hour, right? So T, I'm looking, the question is asking how much do I have after 1 hour? But the problem is I can't put 1 hour because the unit is different. So this is 5 minutes.
Right.
So I have to put 60 for T because it's minutes. They have to have the same units. Okay? So this would be the question, the type of question that you're gonna see. Very important that every 5 minutes, a lot of people, they do mix up the D and the T. D is your doubling time. How long does it take for that bacteria to double? Okay? Same thing with the half-life. So the initial amount, same thing, final amount, the time is T, and then H is the half-life. So the time it takes for the Are we okay with this? So same idea. It will be kind of the same question where you have, let's say, carbon 14, you have 1,000 grams of it, right? And then it's decreasing by half every 100 years, right? So H would be the 100 years, and then 1,000 would be your initial. All right. Now, as I said yesterday, that logarithm is not part of your curriculum. I'm just gonna teach you this as a helpful hint if it's taking you forever to do guess and check. See how we did in the previous example, guess and check, to find the value of T? So anytime you're trying to solve for that exponent, you can use log to solve for it. Okay? And log is a button on your calculator that does say LOG.
Right.
Okay? So if I'm solving for that exponent, what I can do is I can do the log of the answer divided by the log of the base, and that will solve for my x value. So let's try that from the previous example. What did I have? Oops. What did I have in the previous example? I had 2.143 equals to 1.0415 to the power of t, and I have to solve for t, right? So if you, on your calculator, if you do log of 2.143 divided by the log of 1.0415, that would give you the answer for t. What did it give you? 18.7. Our answer was between 18 and 19. Right?
So over means divide?
Divide. Yeah. Which is that was our answer, right? And our answer was 18 between 18 and 19. So this gives you the exact answer that you're looking for. Okay? Yes. If you remember how to. Yeah. Okay, so if I want to look for the answer for example 2a, so 5 equals 1.06 to the power of x, we can sit down and do guess and check if you want. Or we can do log.
Yeah, we said between 18 and 19.
Yeah.
Works.
So what would be my solution for this? What do I have to write?
No.
Log 5.
5.
Yeah.
27.6.
So what do you do if you do that? So what do you get? I mean,
27.6. So if we cannot try it not in the log way, so what do
you have to actually sit down and plug in numbers for x. So you can try it and yeah, it will take longer, obviously, right? All right.
Only that's easy. Divided by so 1.
You're gonna use
I still can't believe it. I still can't believe it.
Okay. Now, what would you do for the next one?
Oh. The same thing. Log 25 divided by log open bracket 0.97 power of 2. Does that work?
No, it's less than 0, it's less than 1.
It would work. Yeah, but I would do this first. Okay. Now, this right here is 0.97 to the power of 2, and then to the power of x, right? I can write it that way, right? So find that answer first, and then do the log. It will be exactly the same thing. But I'd rather if you do it this way, so you don't use your calculator improperly. So what do you get when you have 0.97 to the power of 2?
0.9409.
To the power of x. And then now do the log. And your answer should be negative 2.84.
I get the same.
You would get the same.
I get the same before you.
Yeah. See, as I said, it will be the same as long as you know how to use the calculator. Right? If you actually do this, I'm going to erase it. So if you do log 25 over log 0.97 to the power of 2. Right? And we give you the same solution. How about that one?
Yeah, but what about the x though?
You can't divide it by 3 because that's the exponent of x over 3. You see how I wrote this?
Yeah.
Write that the same way. So what would it be?
Negative 3. Negative
To the power of
To the power
No.
0.97.
To the power of 1 over 3.
Yeah.
Right? Because it's divided by, x divided by 3. So this can be written as 120 equals 0.97 to the power of 1 over 3 to the power of x. What's the power of 1 over 3? What does that mean?
This is a negative 3.
No.
No.
0.25. Is it? No. I'm saying.
No.
If it's divided, so okay, so if it's 1 over 3, it means that we flipped it.
No, that's if you're base. If it's you guys are making things. If it's this, then you flip the base.
Yeah.
What is it in radical form?
It's got a cube.
It's the
That's
cube
the
root.
cube root.
Cube root. Cube root. Cube
You
root.
just said that.
Right? It's the same thing as the cube root. So this is the same thing as this. This is the same thing as this. Right?
Yeah.
Okay. Now, do that on the calculator for me. Should be 0.989898. And if you do log 120 over log,
It's the 2.0.
it's a negative answer. If you guys don't remember this part right here, I'm gonna show you another way. If you don't remember this, I'm gonna show you another way. Okay? So if I do log 120, over log 0.97, right? So I do this over this, it's gonna equal to x over 3, right? So that equals to the exponent, right? And the exponent is x over 3, right? So I can find the answer of this and then multiply it by 3.
Okay, that's more like.
That's easy.
But you need to know both of them,
Yeah.
okay?
Sometimes we.
So that would be 157.18. And then you can do cross multiply. It should give you the same. Okay? So, for the next question, I'm going to try to set it up and solve. You can do a group, class group, you can do whatever you want.